My name is Bob Fay with Excell Battery. I'd like to welcome you to our webinar on downhole battery data analysis with our Criterion 4. Many of you, actually, I'm sorry, I'd like to welcome everybody here from around the world. I think we have a lot of people from the Mideast, so thank you for staying up a little later or working a little later to see this presentation. This is something new for us. I know a lot of you have seen our regular Criterion 4 presentation, but this is going to go a little deeper into data analysis. If you're new to this, we will go briefly into the basics of the Criterion 4, but if you'd like to hear more about it, please contact us at some point. We can give you more details. So just a little bit, who are we if you don't know us? I think a lot of you do, but Excell Battery is, Excell Battery is a battery pack manufacturer. And I guess I'm not sharing the screen, sorry. Here we go. Anyway, I want to share the screen to show you this little bit of a PowerPoint before we go into the data analysis. But who is Excell Battery? Excell Battery is a battery pack manufacturer. We specialize in downhole battery packs like for MWD and other high temperature applications. So we're located in Houston, Calgary, Vancouver, and Toronto. And this webinar is being recorded, so we will put the recording on our YouTube channel, which I'm showing you now. So we also have lots of videos there now showing things like more information about the Criterion 4, battery safety, downhole battery basics, as well as other videos about lithium-ion rechargeable batteries. So if you're interested in seeing more about that, we have information there as well. So what is the Criterion 4? Well, Criterion 4 is our battery gauge. Some people call it smart gauge, but we call it Criterion 4 battery gauge. And we feel it's the most advanced downhole battery monitoring system available on the market today. And it consists of three components. First, the app, which you use to interface with the gauge and see the data and as well set it up for use downhole. There's an interface box that is used to connect the battery to the computer. It also serves as a standalone depassivation device that you could use on any battery. And of course, the gauge itself. This gauge is a small PC board, about 33 millimeters diameter, and it fits in the top one of the end pieces of the battery. It does not add length to the battery. You won't even know it's there physically by looking at it, but it certainly is there to collect data while the battery is being used. So what does it do? Well, there's different measurements. It measures and records battery voltage, temperature, peak and average current, 3-axis shock and vibration, rotation, and it calculates from the data above the stick slip, as from the rotation data, as well as capacity used. It uses the current to measure how much capacity you're using. A little bit about how we measure things, and I'll explain why I'm telling you this now in a bit, but we have different sensors on the gauge that measure at different frequencies. So the battery voltage is measuring 4 samples a second. The temperature is measuring 4 samples a second. The current, 1,000 samples a second. And this is both peak and average current. Shock and vibration, we have a 3-axis accelerometer on the gauge. We'll measure shock and vibration at 800 samples a second. And rotation, 1,000 samples a second. So it also has, as I mentioned, calculated values. Capacity used is basically the integration of current measurements with respect to time. Now, I haven't taken calculus for 40 years, so I'm not sure how to do that, but we probably could give you details how the integration is being done. Stick slip is used in a formula, is taking the max rate of rotation less the minimum rate of rotation divided by the mean rate of rotation. And it gives it as a percentage. So you'll see it on our data as a percentage, like 100%, 200%, 1,000%, and so on. And by the way, we do have a question and answer feature here. So if you want to ask questions, please ask questions. I'll try to answer them. So we'll answer them as we go along. Sampling rate. As I mentioned, they're fixed. They're fixed by the various sensors on the gauge. We have what we call logging interval, which is used to determine how fast you write this information in memory. The sensors are collecting so much information that there's no way we would have enough memory on board to record every single data point. You'd probably use up the memory in a few minutes. The memory on board is 8 megabytes, so that is a lot of memory. It could hold 4 million measurements, which is still a lot of memory, a lot of measurements, but we need to select how fast we write to memory to optimize that memory so it lasts at least as long as the battery lasts downhole. A lot of people ask us, like, how much is this gauge using while it's attached to the battery? Because it is an electronic device. It's going to need to have power from the battery just to keep it, to keep the clock running, to keep it awake or keep it operating for data collection. So when we ship you the battery, it's coming to you in what we call deep sleep. It's where the login is disabled. It's set up for long-term storage. It's going to pull about 200 microamps, but at this point, it's not writing any entries to the log. Once you receive the battery and set it up, I'm going to show you how to do that in a minute here, but the login is now enabled so that you can start logging the data while it's being used. So the max current draw about that point is 0.8 milliamps. Yep. 0.8 milliamps. I'm sorry, let me back up. I'm sorry. Sleep is when you enable the logging, and after it's not doing anything, it will go back to sleep and not use up memory. But at that point, it's pulling about 0.8 milliamps. If the login is disabled, after you enable it, it'll go back to the deep sleep state of 200 microamps. Now, when you actually are using the gauge, the battery downhole, it is awake and actively sampling and storing data. The max current draw at that point is about 3.5 milliamps. And this is, like I said, this is where you're writing entries to the log. So you'll see here when current is greater than the threshold, there is a threshold setting that will determine when the gauge wakes up. The gauge wakes up, it senses current, and it will wake up and start writing to memory. Once it doesn't see that current for a preset time, it will go back into sleep mode. So how does this affect your capacity overall? I'm just taking a typical 29 amp hour battery, like an Excell Tensor style and others, 29 amp hour, 29 volt battery. So if it just stays in deep sleep, the battery's going to last for 16 plus years with 200 microamp draw. The sleep mode will allow it to last about 4 years after you set the logging interval. And then in the typical 300-hour run, 3 to 4% of the capacity of the battery will be used up by the gauge. As I mentioned, there's an inactivity threshold and timer. We set a default. It's usually 18 milliamps and 300 seconds. What this means is if the gauge does not see 18 milliamps for 300 seconds or 5 minutes, it goes back to sleep mode. Once it sees over 18 milliamps, it comes awake and starts recording data. So it can actually go back and forth between recording data and going back to sleep if it doesn't, if it's a very low current. So it's important for you to understand that, there is this inactivity threshold. If you're, the idea here is to conserve your memory while you're actually not using the battery. So presumably if the battery's on the rack, ready to be going to go out to the field, it's not working, it's not powering tools. So you don't want to use up memory while it's just sitting there in the shelf. One thing about this gauge, it will record the data, record the capacity used, even though it is not, even though the gauge is not awake. So if it's sitting on the shelf, we're drawing about, a small amount of current due to something in the tool, but it's not enough to wake it up, it's still going to record that capacity used. So you'll know exactly how much capacity used the battery is using while sitting on the shelf. This is a thing, I know I'm probably answering a couple of questions that people always ask us. A processor clock will drift if it's not corrected routinely. Even your computer will do this. Sometimes the CR4 clock will get ahead of its own, ahead of real time. So, unfortunately, we cannot sync that clock until the actual time is past the last recorded date and the date of file. Otherwise, we get corruption. The data won't work right for you at a later time. So a simple procedure to correct this, because the app won't allow you to sync the time, but you disable logging, you wait for the amount of time that the CR4 clock was ahead of time, then you can sync the clock, and then you enable logging again. So anyways, that'll help you sync the clock if the clock is ahead of time. So when you receive a battery from us, there's three steps, three very simple steps, just 3 clicks of the mouse after you connect it to set up the battery for use. I'm going to show you real time with this here in a second. There's 3 steps. Set the clock, you select the log interval, and you click commit. So I'm going to go to our app to show you exactly how this works. And you'll see it's very easy. So over here, I have it's showing the Criterion app, and I have a battery connected to it. I'm showing the app here. And an actual battery is connected to it. This battery is just as if you were to receive it from us off the shelf. So it's going to say time is not updated on the dashboard screen here. So to prepare for use, you go to the configuration screen by clicking on that menu item at the top, and you're going to see like a 1969 or most likely a early January 1970 date on this pack time of day. What that is epoch, Unix epoch time. It always starts at December 31st, 1969. And I think every processor out there does this. So you need to set the time by clicking on this button. But I just want to point out that you need to make sure the computer time is correct. It should be real time. If your computer is not connected to the internet, it may be off. So you need to make sure that time is correct. Otherwise, the battery will reflect that same time. So you just click set time, and now you're going to see it is showing the current time. The next step is to select a log interval. And as I said, this is where you decide how you're going to use your memory. So we have the drop-down menu here. Select any one of these. I'm just going to select typical, and you're going to see these different measurements are now populated with a log interval. So what this means is, like voltage says 5, that means every 5 seconds it's going to write to memory. Vibration, every 5 seconds it's going to write to memory. What that is going to do is going to take those, as I said, axial vibration, or vibration is sampling 800 times a second. So it's going to take 4,000 readings and writing that vibration data to memory, the average of that vibration data. So another thing I want to point out, remaining log duration. Based on what you set over here, this log duration is going to tell you how much memory you have. This has nothing to do with battery capacity. It tells you how long the battery memory is going to last. So in this case, 625 hours, and that should be plenty for most applications. But you can see how if you change something like that, maximum detail, which changes most of these to 1, now the remaining log duration is 124 hours. So if you really want good data density, the maximum data density, you're going to get about 124 hours of memory usage. Again, this has nothing to do with battery capacity. The battery can last longer than this, depending on the current drain, but This is how long the memory will last. When the memory runs out, it's not going to stop the batteries from discharging. So the third step is, and this is very important, click this commit button, because once you disconnect the battery, it will remember this. If you don't hit commit, everything you did here is not going to be remembered after you disconnect the battery from the IFU. Just go back to the screen. As I mentioned, the interface box is a depassivation device. We do supply a cable to connect to the battery, depending on what the battery is. This looks like a Tensor Kintex style cable that will connect between the battery and the interface. And the interface will connect to your computer via a USB. So I'm going to show that same battery. We'll do a quick little depass to show what happens here. So depassivation, you click on that depass menu button, and you're going to see real-time data. So we have a battery, a 36-volt battery connected here. So there are current or depass parameters set up here. So you simply just hit start, and you're going to get a pop-up window showing real-time depass. It will continue until those parameters are met. In this case, it's going to stop here in a few seconds because it is above 31 volts, which is the recovery voltage. You can see in the background there. But if you want to force it to go longer, you can always raise that recovery voltage to a higher voltage level. Keep going until that is met. So you see here the depass is complete. Click that and it's done. So now I would like to go into what you all came here for, is data analysis. I'm going to show some different examples, some things that we have encountered or seen from customers and such, questions they've had. So I'd just like to show a few case studies. But first, I will show you a data file showing you the features of what the data, what you could do to the data. So I've opened up this data file. These are actual downhole battery files. So you're going to see this. You're going to see the data showing from beginning of the battery log to the very end where they stopped. And you're going to see you can hover over various parts. It's going to show you the different measurements with a timestamp of that, the measurements of that time of day. The different color codes, the different measurements are color coded, as seen over here on the right on this vertical legend thing. And I like to, unless you're really looking at the stick slip, sometimes I like to deselect it just so it cleans it up a bit. So you can deselect different measurements by clicking on these various boxes, and they'll go away until you want to see them. So now we're seeing the data file, probably a little bit cleaner look of it. And you can see the rotation is the purple blue color, showing about 28 RPM and such at that point. And there's various things you could do here. You can zoom in by clicking it and dragging a box over that area. You can just zoom in to that very narrow point in time. And you can see how detailed all the different measurements are, like that. You can also use the slider bar at the bottom by expanding left and right, like that. So if you're trying to look for a particular point in time, you can zoom in on that. You could even drag this slider bar over, maybe to see this area here. Not much was going on there, but also reset the zoom by clicking that box there. We have this thing called show events. If you click that, it's going to show the various times where it went to sleep. It will also show depass over here. I'll just zoom in and you can see that. This particular battery went to a depass at some point. Actually, it's not showing it there. Very, very quick little depass. But you can see the different sleep times it actually went to sleep because the current was very low. Then you have Extrema box, click that, and you can see the max mins of that battery. This window will reflect the zoom level that you selected. Because I'm showing the full battery, it's showing everything. So this battery actually made it to 11.4 amp hours before they decided to retire the battery, even though it probably still had a lot of capacity left. And, peak current of 2.8 amps, radial shock, axial shock, 56, 102, vibration, 6 and 8, GRMS, rotation, a max of 141 RPM at some point. So say you want to find out where that 2.8 amp peak current is, where you don't see it necessarily here. And by the way, because there's so many data points, we do average the data a bit to make it a bit more presentable. You can see this checkbox down here, average data. So you probably won't necessarily see where that peak current is. So the way to find that is once you select the Extrema box, you could, didn't mean to deselect that. You drag that measurement to the top like this, and then you click on this, I don't even know what you call that, less than or equal sign at the top, and it'll find that peak current of 2.843 amps. And here it is right there. So you can see, oh, that happened on November 28th, 11/17, which was pretty much at the beginning of the battery. And you could actually come down here to see that slider where it is in this overall view. Maybe something when they hooked up had a very high current draw. You could also click this thing here to add a marker where that is. So if you want to zoom back out for the overall picture, you'll know exactly where that was in relation to the full graph. We also have what we call a histogram, shock histogram. So this little bar thing in the bottom, just click on that. And in the bottom, you'll see the shock histogram. So each shock level will be represented by a bucket here. So right here, I'm hovering over the 25G. So it had 470 shocks at 25G. Looks like it had one shock at 105G, somewhere along the line. And as I said, you could go find that if you would like to see where it is, probably right there. No, maybe not. But that's one way to look at just how rough things were in, downhole. So actually, I want to do show you that shock histogram will depend on the zoom level. So if I just zoom here, the shock histogram is going to reflect this zoom level up here. I see some questions coming in, but I will try to answer those shortly here. So I'm going to show you, sometimes we do get questions about this. We get a battery sent to us to look at that has a blown fuse. So a lot of times the gauge will show exactly where that fuse blew. Not necessarily why it blew, because that's most likely a tool issue causing a short circuit. But a lot of times we can find exactly where that fuse blew. So this is a battery that had a blown fuse, and you really can't see it by looking at this, but you can see here, I did selected Extrema. It's showing a peak current of 6.754 amps. By the way, the current sensor maxes out around 6.7 to 6.8 amps. So if you see a number like this, it's likely railed, and it's likely much higher than that. So again, I'm going to look for that point in time to see where that happened. Move that to the top, hit this thing over here. Someday I'm going to find out what the name of it is. But here, 6.8 amps right there. And that happened on March 15th, 11:30 a.m. Now, the reason why I think the fuse blew, you'll see, you can see how the current was affected here. So I'm going to click on this scaling feature here on the right to change the current scale to make that average current a bit more pronounced. So you can see the green line is now showing, it's going along about 170 milliamps or so. And then this peak current happened, and all of a sudden the current is now very low. See if I can find where it is, like 6 milliamps or so. And what that is showing is actually the current being drawn from the gauge. So instead of tool current, which is here, now we have gauge current, which is very low. So in other words, the tool is now cut off from the battery because the fuse blew. So the battery is no longer able to discharge to power the tool. So basically what happened here, the fuse blew. So look at that timestamp, 11:30. Over here, 5 minutes later, the gauge actually went to sleep because it was below that inactivity threshold. So this is just a way to find out where a fuse blew. If the gauge was actually asleep at that point, it may not record that. It's only going to record it when the gauge is actually awake and actively logging at that point where the fuse blew. Let me open up this file here. Whoops. I need to, sometimes the memory in my computer isn't going to cooperate very well, so I'm just going to restart the app. And open up that file again. What I want to do is showing you can compare two files on the same screen. So we have this file. I just happen to know that these two batteries were run together in the same tool. So maybe I didn't show what I clicked on that plus sign in the lower left. So we have these two batteries that ran at the same time. I'll go ahead and deselect the stick slip again. And you can see, maybe deselect that again. You can see that the data for these two batteries looks very, very similar. Even this high axial shock is at the same point as this one. So if you want to compare two batteries in the same tool, you just click that plus sign and open up the file below, and you can see, you can just go through and compare these two data files together to see how they work. We're going to close that. I have a battery file here that showed some high shock. Just want to give you a picture of what that is. Sometimes it takes a little bit longer, just depending on how much data was in here. So here we're seeing a lot of data, a lot of high shock. At this point in time, the light green and the light blue lines are showing lots of high shock. We could go to the extrema and see just what that was. So, 91G axial shock, 82G radial shock. So it's probably occurring around here. If you want to get more detail, just, click and zoom. So I'm just trying to show you different ways to look at your data that may indicate something going on, that may indicate, tool damage or whatever. So just different ways you could look at this. So I do have a data file on another screen here, and it isn't there now. So there it is right there. This is a battery that happened to run out of memory, mainly because they set up the threshold very, very low, so it stayed awake for several months. So eventually it did run out of memory. So the way to see that, show events, and you're going to see these type of indications on the log file. Once that happens, it won't record that data any longer. The memory for each measurement will run out at different times because it's using different sectors of the memory. So you can see voltage log is full here, current log was full. So at that point, it's, stop recording memory. This one did happen to keep recording the capacity used, but I believe in this case it did stop as well. So, they started the gauge stayed awake for 6 months and basically sat on the shelf and recorded memory the whole time. So eventually it did run out of memory. The battery didn't stop, but the memory did stop recording memory. So this is just important to keep in mind that you keep that current threshold high enough so that it is not recording background current while the battery is sitting on the shelf. We've found that the default of 18 milliamps and 300 seconds seems to be a good number for most people to make sure that battery goes to sleep when it's not actually doing any work for the tool. So I have a couple examples here of batteries that had actually depleted while it was recording. So just want to show you the indications, the signs of that. So you can see here, this battery went, nice for, looks like about 10 days or so. And then you can see the blue voltage graph is dropping here at the end. I'll go ahead and zoom in there. Once again, get rid of the stick slip so you're not in the way, but you can see the voltage started dropping, drop. And you could also see the capacity used is about 27 amp hours. So that's pretty much into the battery life there. So we'll zoom even further and you could see how that voltage actually dropped down to 5 volts. The gauge will brown out below 6 volts somewhere. So if I show events, you're going to see this thing called time adjust. So what happened, this battery actually, time adjust is our indication that the gauge browned out due to low current. So here, 5.19 volts, the time adjusting occurred. That means the gauge browned out and the load was eventually removed. So the battery voltage actually recovered because there's no current at that point, but it's probably not going to be able to sustain a load after that point. So the time adjust means the gauge, when it comes back away, it's going to take the last known time in memory in setting the clock to that last known time. So otherwise, it would just say at that Unix epoch time, 1969. This is our way to keep the clock somewhat close to what it really should be after a brownout. I have one more battery depletion example to show. And as it gets up here, again, this is a battery that ran its full life and ran out of capacity before the memory, of course, but you can see here at the end, the battery voltage is starting to drop. And we can see how, let me just expand it a bit. You can see this pink current thing running around 1,000 milliamps, which is pretty good. I mean, but you can see the battery voltage is dropping. And maybe there was a battery switch at this point. I'm not sure what it was, but the current went to very low, and you see that the voltage recovered, went up very high, but it looks like they did a depass here, and the voltage again dropped. So I could do the show events, and you could see that depass going on right there. There is a question here about, we've seen some gap in the graph of the memory, and how does that happen? My suggestion is, you can see the gap right here, is to click that show events, and you're going to see the sleep marker there. So if you see these gaps with no other indication, you can pretty much be assured that those are sleep periods. See these gaps here? You click show events, you're going to see sleep. So that means the battery went to sleep, or excuse me, the gauge went to sleep because the current was so low. Probably could see here, what is that current there? A 5-minute period where it was awake, 8:42, 8:47. So the current was very low for 5 minutes. It went to sleep. Something woke it up. Maybe it saw a big current again. So it came awake and then went back to sleep again. So these gaps in the data are due to sleep. And you can see that again by clicking the show event log. So that's most of the things I was going to show you, but let me look at some of these questions. Um, Okay, there's a question here. When you plug in a new battery, when received, configure it, and then click commit, do you always depassivate the battery after this procedure? The tool may sit for weeks before going into the hole. Well, um, I guess the answer to that would be, um, are you able to depassivate the battery at a later time? We recommend you depassivate as close as possible to actually using the battery. If it sits for weeks, you may need to depassivate it again. So even though you configure the gauge and get it ready for use, if you are able to depassivate it at a later time, I would say do it at that time. If there's no other way to do it, yeah, go ahead and depassivate it then. But recommendation is to depassivate the battery as close as possible to the time where you're actually using it downhole. Question, nothing to do with the gauge, but is the fuse user replaceable? In most cases, yes, they are user replaceable. We install them so that you can replace them. It is, depending on the battery type, it could be a bit more difficult than others, but if you want a procedure, we could send you a procedure on how to do it. It is a safe procedure. Simply disconnecting the power wire with the fuse, you're not exposing yourself to a short circuit. So you're only touching the power wire, the positive wire. So it's not a dangerous procedure. It is fairly simple in most cases, but we can always send you a procedure on how to do it. Well, good. Some good questions here. Do we have any solutions for rechargeable batteries for downhole use? Um, Basically, rechargeable lithium ions are limited to about 60 degrees C. So that is usually the limitation for downhole use because downhole is usually a lot hotter than that. But if you do have a very, very cool place that you're using, we probably could work out a lithium ion solution for you. There are limitations. Of course, you have to recharge it. The sizes aren't as big. The energy density is much lower than thionyl chloride, but we do have capabilities of doing that if you would like to do that. Do you have any guidelines for how low is low enough to run your batteries? I believe this question is like, at what point do we recommend to put a battery on the shelf? Well, that really depends on how much you think you're going to need to use it for at a later time. It should, if you get 50% use out of the battery and you want to use it for another 100 hours or so, that depends on how much current you're taking. But yes, you can use the batteries again multiple times. I've seen EBL files with 4 or 5 times downhole runs and still not using up all the capacity. So it you can use the batteries over and over. One little stipulation, if you use a 180C or higher temperature battery, you may not want to try to use it a second time just because those tend to passivate a lot more than the 150, 165C batteries. They may be one-time use only, but that really depends on you and how you use it. Do you ever consider including any capacitor circuitry that would help with high current poles and the associated voltage drops to keep voltage more stable? To this day, we have not done that for high temperature batteries, but I believe there are high temperature capacitors, supercapacitors that could work for this, but it just hasn't, we haven't spent a lot of time, or the customers haven't spent a lot of time looking into that further, but we could certainly look at that and help you do that. The idea there is to help stabilize the voltage with high current drains. It is a common thing. There are a lot of low temp applications using this type of thing. Tataran is one company that does have a system for that. But yes, that is probably out there available. So please contact us and we can look into that. Can we get real-time data analysis? Well, our gauge does have the capability to emit real-time data using a CAN interface. So we have information on how to do that. It will require work between us and you to make sure your tool talks to the battery. But yes, we can do that. We can emit real-time data, and we can do that for you. So just contact us and we will work it out with you. Do we actually need to depassivate a brand new battery? Well, that really depends on your tool. If it's not drawing a lot of current and the conditions are right, then you probably don't need to do that. But I do recommend you do it. Our Criterion interface box makes it easy for that. And along that line, what are the symptoms of a battery that was not depassivated before use? And how does it affect the performance of the battery? Well, the biggest thing is, and I don't have graphs to really show you here, but the biggest thing, if you use a battery that was not depassivated and a large current draw is placed on the battery, the voltage is going to drop. The voltage will drop very low. It could drop low enough that it will cause reset of your tool because it loses power because of the low voltage. So the idea with depassivation is to get it to a point where it's not going to have that high voltage drop. So it's, if you get a low voltage issue with a battery that has not been depassivated, it's probably because it needs a depassivation. Sometimes the tool itself will do it. If you just leave it on, it'll act as a depassivation for it. I think what I'm going to have to do maybe in the future is actually do a webinar on depassivation, go into more detail about that. We have detected that memory gap appear in sleep events while the tool is operating. Why does that happen? Well, the biggest reason is the tool current is probably not high enough to get above that current, that inactivity threshold that we talked about before. So if you think your tool current is operating at a lower current than the inactivity threshold that you can see in the app, you need to go ahead and lower that number. And it is user configurable. I'll go ahead and share that part of the screen. So once again, I'm showing that same battery we looked at before. And this is showing inactivity threshold of 18 milliamps, 300 seconds. And you could change that by clicking on that little pencil thing and making this number lower. I'm just going to get us here, 7 milliamps. So now hit commit. Now that battery is set up so that inactivity threshold is 7 milliamps. So anything above 7 will cause that gauge to wake up and record data. Is it possible to activate deep sleep for storage? To get back to deep sleep, you simply go ahead and connect the battery again and you disable logging. So come over here to the menu and log in disable, hit commit. And so once this battery goes through this 5 minutes, according to this inactivity timer, and lower than this current, it'll go back to the deep sleep mode of 200 microamps because logging is now disabled. So that's the difference between deep sleep and sleep. It depends on what is selected in login intervals. So if login is disabled, it'll allow it to go back to deep sleep. If you have login enabled with one of these, if anything is selected down here, or if you select one of these profiles, it'll only go back to sleep mode. So once again, they'll make it go back to deep sleep for longer storage, disable the login. If I run out of memory, can I write over it and keep going? Well, no, it's not going to write over the memory to keep going. However, as you can see at the top of the screen here, there is an erase button. This is called memory erase. And it will allow you to erase the memory, the data file on the battery. So it won't erase the configuration. It won't erase the capacity used. But if you did use up your memory, go ahead and erase it and you can keep going. I don't recommend you always just erase the memory just to erase it. Only erase it if you need to. If you've run out of memory, you want to keep using that battery. Once I click on that, you're going to see this warning come up. It's going to make you download that data file before you erase that memory. So this is a fail-safe to keep you to have that data on hand if you erase the memory. Let me just look through these questions, see if there's anything else here. Some of these questions are a bit complicated. I'm not sure I can answer them at this point. Please reach out to us, and we could talk in more detail. I'm going to go ahead and show you emails here, both for myself and Trip, who most of you probably know. Please contact us and we can help you along with that. We do have information on our website about the Criterion, more details than what we talked about here. You know, there's the website link, there's a QR code if you want to look at it. And please, we can give you more detailed presentations on the Criterion. Just contact us and we could do that. So I'd like to thank you for your time today. As I said before, this will be available on our YouTube channel at some point in the near future. And once again, thank you for your time and have a good evening for you people over in MENA, and have a good day for North American people. See ya.